Good day, everyone. This is Zen Programmer. Today, we'll be discussing a critical part of the data science process, data pre-processing. This is often an overlooked yet essential step that determines the success of data science machine learning models. I'll walk you through key techniques used to prepare raw data for analysis, ensuring we get reliable and actionable insights. This presentation will not be delving into details of Python code. Let's start by understanding what data pre-processing is. Simply put, it's the process of transforming raw data into a clean format that can be effectively used by machine learning models. Why does this matter? Poorly prepared data can lead to inaccurate predictions and flawed business decisions. Data pre-processing ensures the data quality needed for robust analytics. The first step is exploring the data. We use exploratory data analysis, EDA, to get a sense of the data structure, understand its key features, and identify potential issues like missing values. This is similar to performing a preliminary inspection before making critical decisions, ensuring there are no surprises down the road. In Python, we use basic statistics and visual tools to gain these insights. Missing values are a common issue in data and can significantly affect the quality of our analysis. Think of it like missing information in a financial report. It can lead to incorrect conclusions. We can address this by removing the problematic data, filling in the gaps with averages, or using more advanced techniques like predictive imputation. This ensures that our models are trained on complete and consistent data. Outliers are data points that differ dramatically from the rest of the dataset. They can distort results and lead to unreliable insights. Imagine a single outlier affecting your quarterly revenue analysis. This could lead to a misguided business strategy. We use methods like z-scores and interquartile ranges to detect and handle these anomalies, making the data more representative of normal business conditions. Not all data is numerical. We often work with categories like product types or customer segments. To make this data usable for machine learning, we convert these categories into numbers. Techniques like one-hot encoding or label encoding allow us to capture this information without losing its meaning. It's similar to converting different currencies into a single standard for analysis. Feature scaling is like leveling the playing field. Imagine we're comparing annual sales figures and customer age. Without scaling, the sales numbers would dominate the analysis simply because they're much larger. By scaling these features, we ensure that each data point has a fair impact on the model's predictions. This is particularly important in models that rely on distance calculations like clustering. Feature engineering is about creating new, meaningful variables from existing data. For example, we can extract the year from a date field to analyze trends over time. Feature selection, on the other hand, helps us reduce complexity by identifying the most important variables. This step reduces noise and improves the efficiency of the model, much like focusing on key performance indicators in a business report. To streamline the entire pre-processing process, we use automation tools called pipelines. Pipelines help us apply a sequence of pre-processing steps consistently and save time. It's similar to automating a production line. You define the process once, and it runs smoothly every time. This reduces human error and ensures that our data is handled in a consistent manner. To wrap up, let's review the key points. Start with a thorough data exploration to understand what you're working with. Handle missing values and outliers carefully to maintain data integrity. encode categorical variables, and scale numerical data for fair comparison. Use automation tools like pipelines for efficiency and consistency. By following these best practices, we ensure that our data is well prepared, leading to more accurate models and ultimately better business decisions. I encourage you to consider investing time in this crucial step during any data science project to get the most value out of your data.